In this lesson, we'll configure the flight controller to set up the camera tilt servo. After completing this lesson, you'll be able to map a transmitter input to a flight controller output. Now that we have our flight controller set up and we've set up our controller inputs, we now can take a look at the inputs on the screen. If we take a look at the input screen, we're going to go ahead and start to move the throttle up and notice that the channel value changes. Now currently, again, the arming settings are disarmed, which means that we're not controlling any of the inputs on in this case, the motors. Those are the big things that we want to make sure that we're not accidentally turning on. But the important thing to note is that we're getting throttle input on channel 3. If I hold this stick to the right, we're rolling to the right, rolling to the left. We can pitch forward and pitch backward. And we also have control over the yaw by moving the stick left and right. The next thing that we want to talk about is accessory 0. All right, so this is one of the knobs on the controller. And as I move it to the right, you can see that the value goes up. And as I move it to the left, the value goes down. Now, in order to map that to something that we want, we're going to go to the vehicle screen and notice that in here, we're going to set accessory 0 to channel 5. We're going to save that. We're going to go back to the inputs. So right now, accessory 0 is set to channel 5, which means that as I move the dial, that goes up. So I'm telling the software, in this case, when we save it to the flight controller, that I want that accessory 0 on channel 5 to do something. The next thing that we want to do is we want to talk about the ranges that we want for that accessory. Now I'm going to set the low end of this value to 1000, and then I want to set the upper end of this value to be 2000. So this value right here is 2000, and this is its current position. So as we dial this up and down, we can change the current position. And this number right here is going to be this red mark, which is essentially right in the middle. So I'm actually going to set this down to 1300, and that's where it's going to get to its neutral position or its neutral state. And we'll figure out if these numbers are right once we start to control the camera. Now, in order to actually control the camera, we want to make sure that we go to the output section. And it asks us if we want to proceed. We're going to say no, and we're going to save this, and it'll save that information to the flight controller. And then we'll go to the output screen. So right now, 1 through 4 are controlling each of our motors. You see that northwest, northeast, southeast, southwest is essentially 1, 2, 3, and 4 in terms of our motor numbers. You'll also notice that 1 through 3 and number 4 are set to 490 hertz. And number 5, 7, and 8, which we don't have 7 and 8 in terms of our standard PWM pins, we have it set to 50 hertz. So channel 5, our accessory 0, this is the one that we want to use to control the camera output. So we're going to take this slider and we're going to try to move it up, and notice that nothing changes. Right now it's set to 1000 for min and 1000 for max. We're going to set the max value to 1500, and we're going to save that. So now, after you save that to your controller, what you should see is if you turn the dial on your controller, you can actually move your camera up and down. So these values right here, this 1500 is going to be the max amount that we're going to tilt down. If we say change this to 1700 and we save it, this means that your camera will be able to tilt further down. So as long as you have the available movement to do this, you can have it point all the way down by setting it to roughly 2000 and saving that to the flight controller. And then you can point the camera almost straight down, which allows you to see quite a bit when you're in a hover. We also want to make sure that the most vertical position is the standard straightforward position. I'm not going to worry about looking up at all in this case. So I'm going to save it at 1200. And in my specific instance, 1200 isn't quite vertical, or it isn't quite normal with the plane that we're flying in. So it looks like 1100 in my case is going to be looking straight forward. So now I have a range of values going from 1100 to 2000 that lets me look straight forward in the all the way to the left position on my dial and almost straight down in the all the way to the right position. So this looks really good, and making sure that the camera, again, on the input side of things is set up on channel 5 accessory 0 in our case. That will be different depending on your controller and your setup. But these values right here, 1000 to 2000, this is what we're telling the software is the range of our dial. So at the max position, that value is 2000. At the minimum position, that value is 1000. And in general, the output section is going to be roughly equal to that. Now in this case, 1000 would actually look slightly up. So we can go back to the inputs and we can change this lower end value to 1100 and save it. And that's going to again mimic exactly what my input and outputs are going to be. So now that means that at full left on the dial, what I have is a straightforward view. If I go back and I change my input to say 900 and I save it, what this means is that again, my output is dictating what the camera motion is going to be. And what it's doing is it's actually taking about the last quarter turn on the dial, and the last quarter turn is not doing anything for us. If we instead set the last quarter turn to 1100 and save it, then I'm more evenly mapped to what my output is. So at this point, I have my flight controller configured, my gyro configured, I have the input configured from my controller. I know everything that that moves when I go to my input screen. I can move the throttle up and I can see that throttle value change. And I've got accessory 0 mapped to channel 5, which is the channel that we're looking at on the flight controller, pin number 5. And that is now mapped to my camera. So now I can tilt my camera up and down. Just as a quick note, if you want to use gimbal stabilization, again, you can take a look at pitch, roll, or yaw servos, and we can take a look at the output channel and set that to channel 5, and that will allow us to control the servo that is controlling the tilt on our camera. So again, there's some basic stabilization settings. If you're using a 3-axis gimbal setup, whether it's with servos or whether you're using actual brushless gimbal motors, then you can use the same type of configuration and allow the camera to tilt and pitch and yaw and do all these different things based on the attitude of the entire device, the quadcopter. Again, we're not getting into that. We want manual control, so we're using these inputs and output values so that we can manually tilt the camera up and down. So at this point, notice that we have a green check mark next to save. We can save again if we want to. We go back to our input section, go back to arming. We're going to set it to whichever option you want in terms of arming your vehicle. A lot of people like to use the roll to the right, which means that you'll take the stick that you have set up for rolling the quadcopter and you'll push it all the way to the right, and that'll then arm the motors. I'm going to use always armed on mine because I have my controller set up so that one of my accessory toggles will actually turn that off and not allow me to control anything until I flip that toggle. So again, there are various ways that you can set yours to be armed, but at this time, we can now reassemble the component tray so we can get ready to do our first test flight.